El CIBE genera, aplica, transfiere y difunde las soluciones biotecnológicas que demanda el sector agrícola de la costa ecuatoriana. Su competitividad a escala global está soportada por el arduo trabajo de investigación en áreas de la industria agrícola, con gran prioridad hacia el sector bananero y el cacautero. La oferta de sus servicios especializados abarca a la cadena productiva, generando impacto en el sector agrícola, sector de la agroindustria y el sector de alimentos. Para lograr sus objetivos, el CIBE posee un equipamiento de primer nivel. Ha adquirido a lo largo del tiempo tecnología avanzada basado en las necesidades de investigación. Además, cuenta con un factor humano altamente capacitado en varias universidades de prestigio mundial. El equipo, conformado por varios PhD, másteres e ingenieros, se caracteriza por conocer a profundidad áreas de la agricultura, cultivo de tejidos, fitopatología, microbiología, bioproductos, biología molecular, entre otros. La diversidad de especialistas ha permitido asegurar que su labor está enmarcada en soluciones integrales con un estándar de excelencia y seguridad. El CIBE oferta al sector productivo una gran gama de prestaciones que abarcan desde análisis puntuales de laboratorio hasta investigaciones de tipo aplicada, siempre con un enfoque hacia la innovación y la optimización del uso de los recursos. Algunos de los servicios insignia del centro son clínica de plantas y diagnóstico de enfermedades, bioensayos para evaluación y validación de productos agrícolas, ensayos de resistencia a fungicidas para gestión de cigatoca negra, detección de OGMs en alimentos procesados, uso de laboratorio de contención nivel de bioseguridad 2, almacenamiento de plantas élite y microorganismos de interés. El CIBE ha desarrollado productos que aportan significativamente al crecimiento de la cadena productiva agrícola del país, en diferentes tipos de cultivo, como el banano, cacao, caña de azúcar, entre otros. En los últimos 2 años, el CIBE ha realizado publicaciones indexadas en importantes y prestigiosas revistas científicas indexadas en Scopus y Web of Science, como PLOS ONE, Agronomy Journal, Crop Protection, Applications in Plant Sciences, entre otras. Así, el CIBE plantea seguir desarrollando estructuras y capacidades tecnológicas para responder oportuna y efectivamente a las problemáticas y desafíos que la sociedad demanda. De esta forma, deja marcado su liderazgo en la región en el desarrollo, transferencia y difusión de soluciones biotecnológicas para la industria agroalimentaria.
Buenos días, bienvenidos al webinar Uso de la biotecnología para entender y mejorar la experiencia sensorial en cacao. El día de hoy nos acompañarán 2 increíbles doctores con una trayectoria muy impresionante, con la que vamos a dar el inicio con el doctor Julio Bonilla. La charla va a ser llevada en inglés debido a que uno de nuestros invitados es internacional. Esperemos les guste y las aprovechen completamente. The Professor Julio Bonilla is a professor and researcher at ESPOL, where he develops research at CIBE. He's a biologist with a master's degree in plant molecular biology and PhD in biotechnology from the University of Barcelona, Spain. Since he begins in the field of research in 2009, he has been involved in plant and agriculture research, having worked with crops like banana, cocoa, and tomato. He teaches in the master program in applied bioscience of the ESPOL program and PhD program in applied bioscience of ESPOL. Dr. Julio focuses his research on plant and environmental biotechnology. He is currently studying in the genetic composition of plant species to explain their relationship with the environmental and production factors. Dr. Julio Bonilla focuses his knowledge on the use and exploitation of the potential of plants and strengthened their agronomic characteristics of cultivation through molecular tools that allow him to understand the relationship between plants and factors that surround them. Today, Dr. Julio Bonilla is studying the genetic factors in cocoa that affect his flavors and aromas, and how to use this knowledge to enhance his characteristics and improve its competitiveness in the international market. Welcome, Dr. Julio.
Thank you, Tatiana. So I will share my screen. Greetings, everyone. Thank you for this opportunity. Okay. Okay, I hope you can all see my screen. So for today, I will be talking very briefly about one of the most important topics that we are currently developing while I'm working at CIBE. So it's basically the strengthening of the fine flavor cocoa from Ecuador to enhance their characteristics. So going very into the process of how cocoa is being developed in Ecuador, we can say that one of the most important steps before actually getting to retailing or consuming chocolate is how it is produced. So in that sense, we can say that the cocoa plants are one of the most basic and important factors in this process. 8% of all the cacao that is produced has been classified as fine flavor cocoa. And this is very important because this type of cocoa has been categorized as one of the most special ones because of the aromatic and sensorial characteristics that they express. And in this type of cocoa, Ecuador is leading in this segment. But many other Latin American countries are also betting on these fine flavor cocoa varieties. So what makes them special? So genetic quality is one of the most important aspects to determine how special this type of fine flavor cocoa is. And all these genetic quality or the genetic makeup of this type of cocoa varieties are accompanied by different factors. So it's not only the genetic quality or genetic composition of the cocoa plants that make these fruits so valuable. So it's also a combination of different environmental factors. So, for example, temperature, it could be soil, it could be all the post-harvesting process. So like fermentation, roasting, drying process, all the conching, everything that comes after you have collected the cocoa pods until you have the chocolate. All these steps in between is what actually make them in companion with the genetic makeup of the cocoa, what makes it actually special. So it's not just that the genetic makeup, it's also where, when, and how it is cultivated, these plants. So just getting a little bit more focus on what is actually happening in the market, we can say that from the 100% of cocoa that's being developed around the country, just a small segment of it is what we call cacao nacional, which is what we have qualified as fine flavor cocoa. But many other parts of the segments is what we call the Trinitario, or what we also are cultivating here in Ecuador, which is the CCM 51, which is a very high and productive, highly resistant variety of cocoa, of cacao, that is being cultivated in a long segments of Ecuador. But there is a lot of let's say of battling in between the farmers on deciding which will be the best cocoa, the best strategy to follow to actually have a good competitivity in the market. So they are debating in between CCM 51 and Cacao Nacional. But this is an open debate, and there are a lot of different factors that can affect the decision, and also there is a lot of different actors that play in this, that play an important role in this decision. So during our time talking to some farmers and also spending doing research, we have defined, and literature has also helped us define, that what actually makes cacao, fine flavor cocoa special, it's what the name says, it's flavor, it's aromas. So for this, you need to have a sensorial evaluation to actually determine how special or not, let's say like that, a cacao could be. So for this, the sensorial evaluation is the best method. So you need to, what this means is that you need to taste it, smell it, and feel it in you, so you can actually define how sensory experience that it is giving you this type of products. One of the things is that this type, even though this process is very important to define the characteristics of the fine flavor cocoa, it demands a lot of time, resources. It also requires highly trained personnel. So this is also some things that not everyone could have access to. So this is the things that we are also trying to improve, to actually give this type of, let's say, methodologies or techniques access to everyone. But there are also other type of methodologies that we can follow to assess this type of evaluation, and it's more from the chemical side. So we can have, we can use other type of machines. So we have some machinery, specialized machinery, that allow us to see in within the molecules and understand and try to interpret what these molecules can, what type of sensory experience can these molecules give to us, right? So these are biochemical methodologies, but they also require trained personnel, but they also require high level of technology because some of the equipments might be very expensive. So as you can see, there is a lot of sometimes cons that can affect how can we assess the importance of the fine flavor cocoa. But why do we want to do all this? Why do we want to understand how the molecules are composed? What are they giving to the flavor? How is this composition of all the different molecules, or in this case, volatiles, are affecting the flavor that you can feel in a sensory evaluation? So there are many things that has been described for cocoa. And one you can see here in this brief slide, this chocolate flavor wheel. You can see all these different colors and all the different names within the colors. And you can see that in this wheel, you can actually read all the different type of flavors that can be found in cocoa. So you can have fruity, you can have nutty flavors, caramel, spices, earthy, florals, and within each of them you have a specialized type of note. So all this combination of the different molecules, all this combination in between the genetic factors, all this combination with environmental factors, all these affect what at the end what the consumer will feel when they taste or when they eat chocolate. So this is something that these are some of the things that we are trying to understand. How can we understand how each of these different factors are affecting the final product? And for this, we are trying to develop a type of, we are researching how the genotype, the volatile, which are the molecules, and how the sensorial experience are affecting the production and the evaluation of chocolate by the consumers. So genetic makeup, as I said at the beginning, is just a first part of what actually the equation has. So genetic diversity, which is a very important part of the equation, is not the only one. So we have other things like, for example, fermentation. Then we have how it's being fermented, where it's being fermented, the time. We also have other type of post-harvesting processes, like, for example, drying. So all these different steps affect the final product. So, in collaboration with Ghent University and Kuhn and his research group and other colleagues, I'm going to briefly explain one of the results that we obtain in this journey to understand how genotype is affecting flavors, right? So very briefly, just to tell you that we compare 4 different national genotypes, and the CCM 51, which is our bulk cocoa, what is called in the market. So we very fast, it's the EET 103, 559, 576, and 577. They were compared at 3 different levels. So they were compared at the genotyping level, they were also compared at the chemical level, and they were compared at the sensorial level. Just very briefly, we understood that through this type of biochemical technologies, we were able to identify many different volatile compounds. And you can see here just a small list, a very broad list of what we found. And all this, just as the name says, they don't really tell us anything. These are just chemical compounds. But how do they interact, and how do they affect what we taste, what we smell, what we feel? That's actually the key. So doing this biochemical analysis, the computer, let's say like that, and comparing everything, that how every genotype was composed, right, the composition of each of these genetic different materials, the computer was able to say, oh, this is different, everyone is different, because based on their composition, we could actually assess that they were different. But if we try to translate this into experience, this is not yet an experience. These are just chemical compounds being compared between them, but they don't really tell us what is going on when we have a taste of this chocolate, for example. So then we went to the sensorial classification. So then we have, we make some small bits, and then we have a sensorial panel. So it was many people who was trained to be able to discern different flavors and aromas in cacao, in chocolate. So in that sense, this panel, it was also capable of discerning between the different varieties. So it wasn't just not the chemical part, it was also the sensorial part. So it was trained people who was able to actually discern and make a difference between the different chocolates that they were tasting. So this also enhances and empowers us to keep researching this, because now we have more evidence that genotype is affecting the sensorial evaluation, how the consumer is feeling, tasting, and smelling chocolate. So this encourages us to keep doing this, to keep researching this area. There's a lot of things that we can still do, and we will discuss this further in this talk. But it is very important just to understand that it's not just a chemical, it's actually how the body is interpreting these chemicals to give us an experience. So finally, at the end, this sensorial panel, it was able to discern the differences between these varieties, and they classify differently for each of them. So we can see just very, very fast, we could see that national cocoa was able to give a very similar, let's say, profile, while CCM 51, which is genetically very different to the other ones, gave a different sensory panel result. So it had a different profile, as we call it. So basically, now we are also within the aid with Kuhn's group. We are working in how to enhance this in the search of these differences. How fast can we do it? Because even though this is a very nice result that we saw the difference between the genotypes and the sensory evaluation, and how the taste is affecting the experience for the consumer, it is still a very slow process. So we're trying to develop fast processes that allows us to do this not yet in real time, but as fast as possible, so we can give this technology back to the farmers or back to the producers and let them know, look, this is available, you can use this technology, and you can easily discern the type of cocoa, the profile of your cocoa, what chocolate could you expect from this type of cocoa. So these are some of the things that we're trying to research and keep doing here at CIBE, and on collaboration with Jugend. Thank you.
Okay, thank you, Julio. Very interesting talk. Now, the question will be in the end of the webinar, and now we are gonna give out the talk to Kuhn, but not with small information about him. Well, Professor Kuhn de Wentin is a senior food professor at Ghent University and founder head of the Food Structure Function Research Group, known as the Laboratory of Food Technology and Engineering. In 1999. His research group, Food Structure and Function, varies around 30 people and investigates structure-function relationship in complex food systems based on a multi-scaled approach. Doing so, the group wants to answer the society-driven demand for innovative formulated products that are tasty, healthy, sustainable, convenient, and affordable. An important milestone was reached in 2009 when Kuhn de Wentin founded Coco Lab, that further emerged into UGen's first entrepreneur-driven spin-off company in 2012. Besides founder and owner, he's still chairman of board of directors. This private company translates fundamental science into practical solutions for companies and other stakeholders active in cocoa and chocolate processing. In May 2021, the multifunctional company Purtos participate as a shareholder in the company Coco Lab to help in further develop into an international open innovation center on cocoa and chocolate processing. Since 2002, Kuhn de Wentin is director on behalf of UGen of the Master of Science in Food Technology program. Since 2016, is also chairman of Food to Know. Today, Kuhn is and author of more than 500 publications, of which 333 are peer-reviewed journals, and has supervised 239 master students and 41 PhD students as the promoter. Thank you, Doctor, and welcome to this webinar.
Thank you, Tatiana. Thank you for the kind introduction. So first of all, I would also like to thank Julio and ESPOL for inviting me as a contributor in this webinar. I also have prepared a rather small presentation to illustrate a little bit what we are doing. So I would be happy if you could share it. So what we already mentioned, or what you already mentioned, so is that my laboratory is focusing on the structure-function relationships in very complex food systems, amongst which also cocoa and derived products like chocolate. And that resulted in the foundation of a spin-off company, Cacao Lab, which is a private company related to UGent. And that company is focusing on innovation and training from bean to praline. Next slide, please. Next slide, please. Yeah, so the picture you see here is the microstructure of chocolate. So what you are noticing is chocolate, and chocolate is actually a very concentrated dispersion of particles in a continuous matrix of cocoa butter. So what you're seeing here are actually sugar crystals and cocoa particles, which are embedded in a cocoa butter system. And they all play a very important role. The cocoa butter is very important for the melting of chocolate in the mouth, but the sugar, of course, is important, providing the bulk and the sweetness. And the cocoa particles are also important. They give color to the chocolate, milk chocolate and dark chocolate, but they also contain a lot of important bioactive molecules, like catechin and epicatechin, methylxanthines, like a bit of caffeine and theobromine. And those are very powerful antioxidants with a biological activity. Next, please. So these arrows are showing you the different components in chocolate. Next, please. So Julio very rightfully explained that you need, first of all, to produce high quality cocoa before you can make high quality chocolate. And you all know that I'm coming from Belgium, and Belgium does not have the climate to grow cocoa trees. The cocoa trees, Theobroma cacao, are cultivated around like you have in the country of Ecuador. So in our research, most of the time we start from fermented and dried high quality cocoa beans that are roasted. Now the roasting process is a thermal treatment that is very important to already turn precursor molecules into flavor molecules, amongst which you also have the volatiles, of course, like the furane molecules that Julio already mentioned. Now, after roasting, the cocoa beans are being broken, and there is a winnowing process. And the winnowing process means that we are removing the shell from the cotyledons, which are broken up in what we call cocoa nibs. Those nibs are grinded into cocoa liquor, and the particle size of cocoa liquor is very important toward the quality of the final product. Cocoa liquor is also called cocoa mass, and depending on the temperature, it is mass, it is solid, or at high temperatures, it melts down just like chocolate and you have a liquor. Now, a lot of cocoa liquor worldwide is also being pressed into cake with a certain residual fat content and cocoa butter. And that is actually illustrating the major cocoa raw materials. So you have cocoa mass or cocoa liquor, which is the same. You have cocoa powder, which is produced from the cake, and you have cocoa butter. Those are the important industrial ingredients derived from cocoa beans. Next, please. And this I already mentioned. So cocoa cake can be made in cocoa powder. Now, Belgium is very well known for its chocolate. And you should know that 20% of the worldwide industrial chocolate production happens in the country of Belgium. 20%, that's 1/5 of the global production in a very small country in the center of Europe. And this is already happening for many years. So the production of industrial chocolate, and by industrial chocolate, I mean chocolate that is further processed into end products, that production is based on a lot of know-how by the different big companies in Belgium. So Barry Callebaut is operational in Belgium. Cargill is operational in Belgium. Puratos Belcolade is a third important player operational in Belgium, and Mondelez as well. And why do they do that? Well, one of the most important reasons is that the chocolate, industrial chocolate that is produced in Belgium, can be called Belgian chocolate. And that is for sure a quality label around the globe right now. Next, please. So I will now demonstrate how we can produce chocolate on a lab scale. So a small scale, but still relevant for what happens in the industry. First of all, we mix the ingredients. So you have the cocoa liquor, the cocoa butter, sugar, and also milk powder. Now, milk powder is not always added. So milk powder is added when you are making milk chocolate. If you want to produce dark chocolate, we don't use milk powder. And if you ask me, how can you make white chocolate? And is that really a chocolate? Yes, it is a chocolate, but then we use a lot of milk powder, but no cocoa liquor. But there is still a lot of cocoa butter present in white chocolate. Yes, please. So after the mixing, there is another very important process that is determining the quality of the end product. And this is what we call the refining process. Now, as I illustrated in the beginning of my talk, Chocolate is a kind of dispersion of many small particles in a continuous fat matrix of cocoa butter. But the size of those particles is also very important. So the maximum particle diameter should be 30 micrometers to avoid a sandy mouthfeel. Now, when you compare the particle size and the particle size distributions of continental European chocolate, like milk chocolate or dark chocolate or any other kind of chocolate produced in Belgium, we end up with a particle size of 15 to 22 micrometer. That's the average size. North American chocolate, for instance, has a significant larger particle size, around 20 to So the thing is illustrated here with the 3-roll refiner. Those are rolls which are actually rotating and turning the chocolate mass, which you see on the picture, into a crumbly material in which the small particles have reduced in size. The product becomes drier, we say, because, of course, the available surface from related to all these small particles is much larger than compared to the original particles, which were much bigger. So the available surface is much higher, and that will bind the cocoa butter and turning the product into a more crumbly, dry looking product. Yes? So after the roll refining, there is another very important process that will determine the end quality, and that is the conching process. Now, the conching process is a very intensive shearing process during which you add more cocoa butter, some emulsifier, like 0.4% of lecithin, and this is happening for several hours. And doing so, the final rheological properties, but also the final flavor, the taste, and the aroma of the chocolate is being influenced. For instance, acetic acid is produced in the fermentation process, and a lot of acetic acid is actually evaporated during the conching process. So that is an unwanted molecule that is removed during conching. But the Maillard reaction is also taking place in the conching process, creating new type of taste molecules, which are very essential for the final taste of the product. At the end of the conching process, the chocolate is, you could say, finished, but it is still in a liquid form. It can be stored in a liquid form, even for transportation to the final company where it is turned into an end product. Or, of course, in the end, it must be turned into a solid chocolate, and that is happening in a controlled crystallization process. Next slide, please. That is the conch inside. Next slide. Yeah. So the tempering or the pre-crystallization process is also very important related to the final quality, because in the end you want the cocoa butter to be crystallized to a large extent, but in the exact right polymorphic crystal. That means the beta crystal, the beta 5 crystal, that is the crystal you want to have in the end. Now, the problem is that you cannot create those beta 5 crystals directly from the molten chocolate. You need to first cool down the chocolate, for instance, on this marble plate. By stirring it around, you create unstable, unwanted crystals and stable crystals. And then by heating up the chocolate, by adding more warm chocolate again, you are melting out the unstable crystals, only keeping that desired polymorphic crystal, the beta 5 polymorph. And that beta 5 polymorph is very important because that will ensure that the chocolate will have the desired glossiness, the desired melting profile in the mouth, and also the desired snap. That is the noise that chocolate makes when you break it, for instance, with your teeth. Yes, please. So I explained or illustrated already that the production of Belgian chocolate is very important because 20% of the worldwide production happens in Belgium. That is the industrial chocolate. But we also have what we call Belgian chocolates with an S. And the most important Belgian chocolates are the pralines. Those are filled chocolates. Next, please. So Belgium is also very well known for the pralines. And you could say that the praline, which is a filled chocolate like illustrated in these pictures, is invented in Belgium. Actually, there was a famous chocolatier, Neuhaus, who invented the praline. And now chocolates pralines are being made by several famous companies, and Neuhaus, Godiva, Leonidas, Gillian, and a lot of small and medium-sized enterprises as well. So also this is a very important product. And for instance, in major airports, you can always buy Belgian chocolates and bring them home after some traveling. Yes, please. So the production of those chocolates is very important. And now, besides doing research on chocolate, next slide, please, we also organize a lot of trainings. And we have a famous workshop that we organize biannually, the Cocoa and Chocolate Processing Workshop. And in the past, we had participants coming from 20 countries worldwide. And also people from Ecuador, let's say, attended this workshop. And after the workshop, they made their own chocolate manufacturing company. Next slide is showing you a picture of the graduation ceremony of the last edition that we organized in 2019. Obviously, it was the idea also to organize this workshop in 2021, but we all know the reason why we could not go ahead with this. Of course, it had to do with the COVID-19 pandemic. But next, we are still planning, hopefully, fingers crossed, to organize the 7th edition in 2022. And we would be most happy if we could also receive participants from Ecuador. So if you follow us on our on Facebook or our website, you will have the updated information with respect to the organization of this workshop. Now, have we already collaborated with Ecuador? Yes, we did. We actually did a 4-year research with Ecuador. It was done with EPN in Quito. Next, please. And that resulted in the PhD thesis, which was defended a while ago by Haley Rotiers. And in that PhD thesis, that research that took 4 years, Haley, she studied, let's say, from genetics to flavor dynamics, the sensorial profiling of fine and bulk Ecuadorian cocoa. And that brings us back to the presentation of Julio, because also in this thesis, we investigated the bulk Ecuadorian cocoa, CCM 51, with typical fine flavor varieties. So, that's why I'm so happy that ESPOL and UGent decided to continue this research in a collaborative format for the next years. So we really look forward to collaborating with Ecuador in this very important area of fine flavor cocoa. And please do not forget, cocoa originates, of course, from Latin America and Ecuadorian cocoa. And I'm not telling you this because I'm having this contribution in this webinar, but it is everywhere accepted that one of the best fine flavor cocoa in the world is the Ecuadorian cocoa. Of course, we have to make sure that the future is okay with respect to that, because of course you need to preserve these high fine flavor varieties for the future. So the diversity is also very important. Next, please. So these are my contact details and also the ones of Claudia Del Bar, who is the general manager. So please feel free to send us an email, follow us on Facebook, Twitter, or LinkedIn to get updated information on what we're doing on cocoa and chocolate research. Thank you for your attention.
Thank you, Doctor. Very interesting talk. I think everyone has been learned a lot of the stuff to create chocolate or good chocolate like the Belgian is. Let me check the comments and any questions. The we have one question. I don't know if for you or for Dr. Julio, but I will tell them. The intention of making a sensory profile is to give a value to the commercialization of chocolate. This technology will be profitable in countries like Ecuador.
Well, I think it's more like a comment than a question, but yes, I do agree that this sensory profiling of chocolate, yes, it gives added value to the commercialization because, as I agree with Kun, it is openly said that Ecuadorian cacao is the best cacao, but we need to work on it as well. So it's not just let it be the best one, let's try to be even better. And one of the things that we can try to do is understand better how the genetics in our cacao is making one of the best chocolates, accompanied by the know-how, for example. So technologies like allows us to understand the sensory profiling and how we can achieve this sensory profiling can be very profitable in countries like Ecuador, because nowadays Ecuador is known for producing cacao, but not for producing chocolate. So that's one of the barriers that we can also tackle, is not just being good producers, but also be good producers of not just, good producers not just of cacao trees on cacao pods, but also of good chocolate. So that's something that we can be working on. So yes, I do agree with this commentary, and sensory profiling can give added value to chocolate, not just Ecuadorian chocolate, but any chocolate. I don't know, maybe Kun, you want to add something?
No, I can only agree more. So you expressed it very correctly. Yes. So that's why we collaborate not only with Ecuador, but also other countries around the equator, let's say, because it's not only about making high quality cocoa, but we're also, let's say, stimulating, helping those countries to create added value on their products, and from their cocoa also produce high quality intermediate products, but also end products. And that makes it so nice, because also this chocolate and cocoa workshop we organized, people from countries like Ecuador, they come actually to Belgium, learn how to make high quality chocolate, and set up their own small companies, turning in a kind of bean to bar format the high quality cocoa into chocolate. Yes, that's very important. Yeah.
I don't know if there's another question, but I also wanted to maybe bring something into this talk. Is so we have been discussing so far, Kun, about okay, so genetics is important, and then we know that chocolate producing steps is also important. But what is the bridge in between? So there's a lot of things that we are still interested in, and as a part of the collaboration that we were discussing briefly during our talks. We want to expand what you have already done with Haley. So one of the things that we are trying to achieve right now is understand and the genetic makeup, how the genotyping of the cacaos in Ecuador can affect the producing of high quality chocolate. Mm-hmm. So in this sense, we have started a new research, and this is like the new collaborations that we are initiating nowadays. So maybe we can talk a little bit more of what we are trying to achieve throughout these
yes,
collaboration.
Yes, of course. Well, if I can start by saying, high quality cocoa, fine flavor cocoa is one thing, but then first of all, you need to harvest it and ferment it in a proper way. Because if the fermentation is not carried out or not carried out properly, high quality cocoa, fine flavor cocoa, will not result in a high quality end product. So the fermentation is also something that needs to be done very carefully. And that is followed by drying, because if you don't dry properly, you can have molds growing, and that can even produce toxins, which is also something which is clearly unwanted. But even then, when you have the cocoa, fermented dried cocoa, also roasting can destroy a lot of interesting volatiles that are present in fine flavored cocoa. For instance, in the research of Haley and continuing up today, we know that fine flavored cocoa should be roasted under rather mild conditions. Otherwise, you are destroying the fruity floral components. So every step in the chain of production from fine flavor cocoa to the end product is very important and needs to be controlled properly.
Yes, indeed. It is important, as you were mentioning also during your talk, not only during the roasting, but also, for example, the conching process. It also can have some good or bad outputs depending on how it is performed. So, for example, acetic acid could be volatilized, evaporated during the conching process, which is a good thing because we don't want that type of molecules in our final product.
Yes.
I don't know if there's another question, maybe?
No, there is not any other question.
Okay. So also one of the things that I wanted to discuss is so during, for example, during this presentation and when I was able to collaborate with you and Haley in that work of profiling, right, the bulk cocoa and fine flavor cocoa from Ecuador from genotype to sensory experience. One of the things that I also think it is very important is that it's not only that we need to understand how the product is made and how to make high quality end products, but also how to understand what needs to be done in order to get to it. So, for example, as you mentioned, is not just the harvesting, but also the fermentation, the drying process, and the chocolate producing. And nowadays, Ecuador is a lot of people have bet into the chocolate market. So many small farmers, well, not all of them are small farmers, but many also small farmers are betting into getting into the chocolate industry. So they are having this idea from the bean to bar. So trying to go from their own collection of cocoa, harvesting, fermenting, drying, and well, one of the things that in real life, like for example, if you go to the field, it is very difficult to find a single variety planted in a farm. So it's not like except that CCM 51 from fly flavor cocoa, for example, the national varieties, it's not usual, let's say like that, to find a farm with a single national variety. So you have a combination in there. And I think this is very important to mention because many of the different research studies that have been done are focused sometimes in a single variety. But this is not really what's happening on the field. So if you go to the field, you don't find a single national variety in the farm. So you have a combination. And I do think that there's a great potential in understanding how that mixed, how that combination of genetic makeups can affect the final product. So probably that could give us new, let's say, tools if we understand how to use them correctly, and to know how they can affect, and we can give new tweaks to the final end product, like for example, chocolate.
Yeah, I agree. For instance, in our research with Haley, we noticed, based on the genetic analysis with the SNP method, single nucleotide profiling, that CCN had very, very less variability. So CCN is a very well controlled, CCN 51, very well controlled variety, not a lot of scattering in the results. However, we investigated several so-called national varieties, and there the scattering was immense. So what is called national is actually, and I don't want to sound rude, but it is a very, very wide diversity of many fine flavored cocoas, of which very often, let's say, the farmers do not really know what they're having in their hands. So that's why this research, which we are planning together with very controlled genotypes, is very important. So in the future, we know with what variety we are working exactly. Absolutely.
Yeah, I agree.
I think there is no more comments about. Once again, thank you very much for this amazing webinar. I think I told for everyone that we learned a lot. I never see the process to make chocolate, so this is very interesting for me and excited to see how to develop or generate chocolate from the beans. So thank you very much for this webinar, and hope to create a very strong alliance between us.
We look forward.
We look forward. Okay, thank you.
Thank you. Bye-bye.
Thank
Stay
you, everyone.
healthy
Thank you,
and safe.
Kun.
Bye-bye.
Thank you, Tatiana.
Thank you, Julio. Thank you, Tatiana. Bye-bye.
Bye.
Goodbye.